the beginning, there was silence. Not the silence of absence, but the silence of infinity. Thick, eternal, unbroken. A cosmos suspended in darkness, its vast oceans of void stretching farther than thought can travel. Galaxies drift like cold embers across an endless night, their light fragile against the weight of eternity. And yet, the darkness is not empty. Beneath this frozen sea lies something deeper, something that does not shine, does not burn, but pulls. A singularity, a gravity well so absolute that space and time themselves collapse into its core. For eons, it has slumbered in the heart of a galaxy, unseen, unmoving, a perfect stillness in a universe forever in motion. But now, a whisper, a ripple in space-time, older than the first starlight, threading its way across billions of light years. It is faint, almost nothing, yet it should not exist. Something within the blackness has stirred. Not a star, not a galaxy, but the very engine of annihilation, the singularity itself. What does it mean when the unchanging begins to change? When the most immutable force in nature murmurs with an unknown rhythm? This is not a warning of destruction, but of unraveling, the loosening of constants, the bending of laws, the warping of time's arrow. Perhaps the universe is not a silent stage after all. Perhaps, in the deepest dark, something waits. Not alive as we understand life, but vast beyond imagining. And now, it begins to move. The early decades of the 21st century marked a profound transformation in the way humanity listened to the cosmos. For centuries, telescopes had given eyes to the sky, turning starlight into stories, spectra into science. But in 2015, the universe gave us something new, not through light, but through sound, a sound woven into the fabric of space-time itself. When the Laser Interferometer Gravitational Wave Observatory, LIGO, recorded the first gravitational wave, it was as though the cosmos exhaled after 13 billion years of silence. Two black holes, locked in a fatal embrace, collided with such fury that they warped the geometry of reality, sending ripples across the cosmic ocean. Those ripples, faint beyond imagination, traveled for more than 1 billion years before brushing against the Earth and against the mirrors of LIGO's arms in Washington and Louisiana. For the first time, humankind heard the universe speak without light. That sound changed everything. It validated Einstein's century-old prediction, etched into the mathematics of general relativity, that gravity is not just a force. It is the bending and flexing of the stage upon which all matter moves. From that moment, astronomy ceased. To be purely visual, it became tactile, acoustic, gravitational. Instruments like Virgo in Europe and later Kagra in Japan joined the chorus of detectors, forming an intercontinental ear pressed against the fabric of space-time, listening for whispers of cataclysms in the dark. For nearly a decade, these whispers told a consistent story: collisions, black holes merging, neutron stars colliding, rare violent events producing brief bursts of gravitational waves that rose and fell like distant thunder. Each detection expanded our understanding of gravity, matter, and cosmic history. Yet, all followed patterns predicted by theory until 2025, when the pattern broke. It began quietly, as most revolutions do, not with a bang, but with a tremor so subtle it could have been a mistake. In February 2025, as Earth moved through the deep winter of its orbit, LIGO registered a signal unlike any before. It was not a chirp, not the rising crescendo of two black holes spiraling together. It was something else, a hum, low and steady, persisting for hours. At first, it appeared as a smudge in the data, a soft blur where the clean silence of spacetime should have been. Scientists at Hanford and Livingston assumed it was instrumental noise, a thermal fluctuation perhaps, or a minor misalignment. After all, gravitational waves from cosmic collisions last mere seconds. This one lingered like an echo that refused to fade. It defied classification. They flagged it, logged it, and moved on. But the anomaly returned. Days later, it surfaced again. Not identical, but hauntingly similar, and from the same general region of the sky. By April, the anomaly had been recorded 5 times. Each time, the signal shared the same unsettling traits: a narrow frequency, band, almost like a note, holding steady with a precision that no natural merger could sustain. It was faint, far fainter than anything expected, but unmistakably real. Still, skepticism held strong. Noise plagues every frontier of measurement. Instrumental artifacts can mimic signals, and nature often conspires to confuse. Yet, when Virgo confirmed the same anomaly weeks later, doubt began to erode, and then Cagra heard it too. 3 independent detectors, separated by thousands of kilometers, all listening to the same phantom note in the dark. The data, when combined, painted a stark picture. The source was not in our galaxy, nor in any neighboring cluster. It originated from an unlit expanse, a void beyond the filamentary structures of the cosmic web, a region astronomers often called the desert of galaxies, where matter thins to near emptiness. No supernova, no inspiraling black holes, just silence, except for this. The hum, as it came to be known, was persistent. It did not behave like a transient event. It pulsed with a rhythm that almost suggested intent, a cadence buried in the trembling of spacetime. That idea alone unsettled even the most disciplined minds. Nature is chaotic, indifferent, yet this signal felt composed, ordered. Some even called it music, though that word carried implications too heavy for science to bear. Teams scrambled to find alternative explanations. Could cosmic strings, hypothetical, remnants of the early universe vibrate like this? Could it be a flaw in calibration algorithms? Could distant magnetars, spinning with ferocious magnetic fields, mimic such waves? Every hypothesis collapsed under scrutiny. The signal's stability defied known astrophysical sources. It was too constant, too pure. By summer 2025, the collaboration, meetings grew tense. Papers circulated under pre-print embargoes, filled with cautious language. Persistent gravitational anomaly detected in intergalactic void. But behind closed doors, the conversations ran darker. What could generate such a hum in spacetime? If not a merger, then something static, something colossal yet invisible, a presence that bent the laws we thought immutable. Some theorists whispered of singularities, not the raging mouths of stellar corpses that swallow light in violent accretion, but something deeper, a naked singularity, exposed beyond its horizon. General relativity forbids such things, cloaking singularities behind event horizons like curtains shielding the unbearable. Yet, if the hum was real, if it was born from a singularity itself, then nature had lifted the curtain. The official stance remained cautious, an anomaly of unknown origin. But history has a pattern. Today's anomaly becomes tomorrow's paradigm shift. And as instruments continued to listen, the hum did not waver. It strengthened. Across the world, in sterile control rooms and midnight offices, researchers stared at screens plotting curves that should not exist. Men and women who had devoted their lives to the order of the universe felt that order tremble. For the first time since LIGO's dawn, the song of spacetime carried a note that theory could not resolve. And in the quiet between data streams, an unspoken question lingered. What if something in the dark had begun to move, not in space, but in the structure of reality itself? In the history of science, certain discoveries do more than surprise. They rupture the fabric of certainty itself. The hum, faint and unwavering, soon became one of those fractures. At first, the anomaly had been approached with the clinical detachment that defines scientific rigor. Data was verified, instruments recalibrated, simulations run across clusters of supercomputers. And yet, each layer of scrutiny deepened the wound in reason. The signal was real. What unsettled the community was not its existence, but its nature. Black holes are famously mute, their horizons sealing off sound and light, locking secrets beyond reach. Only in their violence, when they collide, when they feed, do they announce themselves, not in light, but in gravitational waves that ripple outward in a brief dying scream. The rest of the time, they are silent. Perfect silence. But this was different. The hum did not rise and fade like the fleeting crescendo of a merger. It persisted, a slow, unbroken resonance threading through space-time, as if the universe itself was holding a single, unwavering note. And its source, triangulated through the choreography of LIGO, Virgo, and Cagra, lay not in a galaxy teeming with stars, but in the loneliest of cosmic deserts, a region stripped bare of matter, where even intergalactic gas thins to whispers. There, in the hollow between clusters, something sang. The pattern defied classification. Gravitational waves are predicted by Einstein's general relativity, but always in motion, ripples born of chaos. Nothing in relativity allows for a static singularity to produce waves. For a black hole at rest, the geometry of spacetime is eternal, unchanging. No pulse, no song. And yet the hum endured. The questions multiplied like echoes in a canyon. Could it be an artifact? A trick of data entangled, with terrestrial vibrations, the subtle flexing of Earth's crust feeding phantom signals into the detectors? That hope lingered briefly until the signal appeared across multiple observatories separated by oceans, their instruments isolated, cross-calibrated, immune to local interference. It was not an error. It was not earthly. If not a flaw, then what? Relativity is merciless in its clarity. A black hole is defined by its event horizon, a one-way membrane sealing everything inside, even light. Beyond it lies the singularity, a point where equations surrender, where curvature soars toward infinity. According to theory, this region has no voice, no mechanism to reach out. Its silence is absolute. The only leakage allowed by physics is Hawking radiation, a whisper of particles slipping away through quantum fluctuations at the horizon. But Hawking radiation is faint beyond imagination, its timescales stretching into the trillions of years. It cannot hum. It cannot produce the sharp, coherent pattern now etched into the detectors. The shock was not just scientific, it was existential. If the hum came from a singularity, then something inside the horizon was stirring, something not accounted for in the grand edifice of Einstein's theory. For over a century, general relativity had reigned unchallenged, its predictions carved into the bedrock of cosmology. Even quantum mechanics, unruly and paradoxical, bowed to its dominion on the cosmic scale. And now, a signal trembled through space-time like a rebellion. Teams began to dissect its structure, plotting its waveform with forensic precision. It was rhythmic, almost patterned, not random noise, not a chaotic burst, but a sequence repeating with eerie fidelity, a frequency stable to 9 decimal places, unwavering across weeks of observation. Nature is rarely so precise outside the realm of atomic clocks and pulsars. To find such order in gravitational waves from a void-bound singularity bordered on the impossible. Some speculated about exotic astrophysical phenomena, boson clouds, formed by hypothetical ultralight particles swirling around black holes, draining their spin and radiating gravitational waves. These scenarios had long lived in the margins of theory, mere mathematical curiosities. But even these models faltered. The hum's persistence defied the expected decay. No energy source should sustain it for this long. It was as if the black hole was feeding without matter, drawing power from a reservoir science could not name. Others reached deeper into the abyss of speculation. Could it be quantum gravity at work? A Planck-scale structure beneath the horizon, vibrating in ways our equations cannot yet imagine? Could space-time itself possess modes, harmonics, that awaken under certain conditions? Such questions were heresy, and hope intertwined, for they hinted at a glimpse beyond Einstein, into the unified theory physicists have sought for a century. But the most unsettling question was not technical. It was philosophical. Why does the signal seem deliberate? Not in the sense of intent. Nature is not conscious, but in its geometry, its immaculate precision. A hum without drift, a pulse without chaos. In the cold lexicon of mathematics, such order demands explanation. In the human mind, it stirs unease. The absence of light deepened the mystery. Black holes, when active, reveal themselves through X-rays blazing from their accretion disks, through jets that lance across millions of light years. This object emitted nothing. Telescopes swept the region in radio, optical, and gamma bands. They found only darkness. No star, no quasar, no flicker of electromagnetic life. The singularity was invisible, and yet, through gravity alone, it spoke. In late 2025, a closed session of the international collaboration convened to address the anomaly. The presentations were clinical, slides of Fourier transforms, plots of residual noise, probability curves, but the air carried an unspoken gravity. If the signal was real, if its source was what the equations implied, then physics was standing on a fault line. One voice, breaking the sterile rhythm of data, asked the question aloud. What if the event horizon is not a horizon at all? Silence followed, not because the room lacked answers, but because the question was an invitation to dismantle a century of understanding. If the horizon leaks, if something within can reach beyond, then the singularity is not sealed. It is active, dynamic, perhaps even evolving. The hum continued, indifferent to debate, threading its note through space-time like a distant bell. Instruments logged its cadence while human minds wrestled with its meaning. Was it a relic of the early universe, a fossil vibration of cosmic birth? Or was it new, an emergence unfolding now in the darkness beyond galaxies? No consensus formed, only questions grew. And in the long corridors of observatories, under the glow of monitors tracking the heartbeat of a void, a realization settled like frost. The universe had broken its silence. And if the singularity could speak, even in whispers of gravity, what else could awaken in the dark? In science, every breakthrough is a doorway. Some open onto clarity, others into deeper corridors of darkness. When the hum refused to vanish, when its resonance tightened around the laws of nature like a quiet paradox, humanity did what it has always done when confronted by the unknown. It built better instruments and listened harder. The first to turn its ear was LIGO, reborn in silence and ambition. By 2025, its detectors stretched farther than they had in the decade before, their arms honed to sense distortions 10,000 times smaller than a proton's width. Upgrades had stripped noise from the Earth's restless crust, isolating space-time's whispers from terrestrial clamor. Yet even this refinement was not enough. Above Earth's atmosphere, a new sentinel stirred. The laser interferometer space. Antenna, LISA. 3 spacecraft, flying in an immense triangle 4 million kilometers wide, orbiting the sun like a slow, deliberate constellation. Its purpose was profound. To feel gravitational waves at frequencies too low for Earthbound detectors to catch. Waves born not in moments of violence, but in epochs of cosmic breath. LISA's arms of light, stretched across the vacuum, promised a vantage unshaken by earthquakes, storms, or the tremors of human activity. When LISA joined the search, the hum deepened into certainty. It was no illusion of ground-based instruments. From its vantage far from Earth, the signal came clear, its pattern matching LIGO's reports with chilling precision. What had been a faint murmur now revealed complexity, a structure hidden in the oscillations, subtle variations in amplitude like the pulse of something alive. But it was not LISA alone. Across the galaxy, an even older network joined the vigil, pulsar timing arrays. For years, astronomers had watched these stellar clocks, dead, suns spinning with inhuman constancy, using their radio pulses to map spacetime's fabric. If gravitational waves swept through, They would stretch and compress the intervals between those pulses, marking time with cosmic distortion. And now, from the faint heartbeats of pulsars thousands of light years away, came the same rhythm. The hum was not a local ripple, it was a tide. Its persistence was unsettling. More unsettling still was its growth. Each observation suggested a subtle rise in amplitude, as though the source was gathering strength, its resonance swelling against the void. Waves that should decay over distance, fading like ripples on a pond, refused to fade. Instead, they rang on, a background tolling that would not die. The term emerged in hushed discussions. Gravitational ringing. Triangulation traced the origin to a point so remote it strained imagination, far beyond the clusters that bind galaxies into cosmic continents, beyond even the filaments that weave the great web of matter. It lay outside the vast sprawl of Laniakea, the supercluster that shelters our own galaxy. There, where darkness reaches its purest form, in the emptiness between all things, the hum was born. Void regions have long fascinated cosmologists. They are the universe's hollow bones, immense caverns of near-nothingness, where density falls to whispers, and galaxies drift like lonely ships. In these regions, gravity loosens its grip, and light seldom passes. Yet even emptiness has geometry, subtle curves and warps written by the hidden scaffolding of dark matter. These places are not dead, they are dormant. And now, in one such void, space-time itself seemed to tremble. Probes and telescopes swept, the coordinates, casting their gaze in radio, infrared, and X-ray. They found only silence, no galaxies, no dust, no intergalactic gas. Not even the faint murmur of the cosmic microwave background showed anomalies there. Matter was absent, energy was absent. And yet gravity spoke. The hum was not accompanied by light because there was nothing to shine. What stirred in that abyss was pure geometry, curvature without substance, an unseen architecture flexing against the void. Then came the deeper anomaly. The waveform analysis revealed not just constancy, but acceleration. The pulse grew stronger. With time, its frequency creeping upward by fractions too slight for the ear, but undeniable to instruments tuned to space-time's vibrations. Something was changing at the source. Something dynamic, where dynamism should be impossible. Black holes, once formed, are thought to sleep unless disturbed by infalling matter. But this was a crescendo. Theories fractured under the weight of new data. Could an ultramassive black hole, billions of solar masses, dwell alone in that? Darkness spinning with titanic inertia. Spin can drive emission through exotic processes, but only if the black hole is surrounded by matter to interact with. There was none. The void was clean, a canvas without paint. Yet the waves came stronger, the note tightening like a string under tension. Speculation wandered into dangerous territories. Perhaps the object was not a black hole at all, but something stranger, a naked singularity, stripped of horizon, exposing the raw edge of space-time to the cosmos. General relativity forbids such things, cloaking singularities within horizons to preserve causality. But if that law had cracked, if the horizon had thinned or fractured, then the singularity was no longer sealed. It was visible, not to light, but to gravity, and what lay beneath could now stir against the universe. As models multiplied, so did questions. Why there in the cold cathedral of a void? Why now, after eons of silence? Was this a relic awakening or a birth unfolding? Some pointed to the early universe, to primordial black holes forged in the furnace of creation, objects older than galaxies. Perhaps one of these ancients had survived, slumbering in darkness, now quickening for reasons unknown. Others ventured into the speculative fog of quantum gravity. Could the hum be the heartbeat of a phase transition, a shift in spacetime's own structure? If the vacuum is not empty but seething with energy, then a rupture could echo through reality like a bell struck at the base of existence. And if so, What was the cause? A fluctuation? A critical threshold passed after billions of years? Or something external, something that touched the universe from beyond? The anomaly pressed humanity to the edge of comprehension. Instruments logged terabytes of data. Observatories convened in midnight conferences. Models bloomed across networks of supercomputers, yet the essence remained elusive. For every layer stripped away, another emerged, darker and more intricate. And still the hum grew stronger, a signal that should not exist. A pulse threading through the lattice of space-time, swelling as if in preparation, and in the sterile glow of control rooms, in the quiet between calculations, a thought began to take root, not spoken, not written, but shared in the silence of minds. What if this was not a remnant of the past, but the prelude to something new? For months, the hum lingered like a thread woven through space-time, a low, unyielding tone carried on a medium that is itself reality. At first, it was a curiosity, then a problem. And now it had grown into something far more unsettling, a force that refused to fit inside the walls of known physics. The data showed what no theory wanted to bear. The signal was not static. Its amplitude, though subtle, climbed with time. Its frequency shifted, not erratically, but with an order so precise that randomness could no longer be invoked as refuge. The hum was evolving. Something was changing, in the source, and that change came with an impossible cost: energy. Gravitational waves are not mere abstractions. They carry energy, draining motion from colliding stars and collapsing giants. Every ripple that reaches Earth is a faint echo of a vast expenditure, a transaction of matter into pure geometry. But here was a paradox that gnawed at reason. The void-born hum bled energy into the cosmos without a trace of a fuel source. No swirling accretion disk to siphon. No tidal interaction to exploit. Nothing but silence and the black mathematics of emptiness. Where, then, did the power come from? The conservation of energy, bedrock of physics, the law that binds every process from an atom's spin to a star's birth, quivered in doubt. If energy could emerge from nowhere, then the pillars of science cracked at their base. Some argued for measurement error, others invoked exotic processes, quantum superradiance, hypothetical axion fields. Yet none could account for the scale implied by the hum's persistence. The source was radiating gravitational energy at a level rivaling stellar cataclysms, and it was doing so in perfect stillness. Then came the second revelation, one that darkened every room where physicists gathered in quiet debate. The waveform, analyzed across months, revealed modulations that should not exist, signatures of internal dynamics. Not surface ripples, not external interactions, but deep-seated oscillations, as though something inside the singularity itself was moving. For a century, black holes had been treated as simple creatures. Strip away their accidents, and only three numbers define them: mass, spin, charge. No complexity, no motion beyond their birth throes. But the data whispered otherwise. It suggested layers, degrees of freedom hidden beyond the horizon. Something inside was stirring. And so, a question once confined to the fringes, to the speculative margins of theoretical conferences, stepped into the center with the weight of inevitability. What if black holes are not endpoints, but processes? Not tombs, but engines. Engines of what? No one dared to say. In hushed conversations, names surfaced: loop quantum gravity, string theory, holographic duality. Frameworks that promised to pierce the veil of singularity and reveal a quantum architecture, humming beneath Einstein's smooth space-time. Could this be the first fracture, the first empirical tremor of that unseen realm? Could Planck-scale structures knotted in geometries smaller than thought can hold be flexing now against the horizon, letting their vibrations seep outward as gravitational waves? Some models took a darker turn. Suppose the event horizon is not an impenetrable wall, but a membrane, a limit, not a law. Then what if something beneath has begun to tunnel through? Quantum tunneling is not a stranger to physics. It drives the nuclear furnaces of stars, lets particles escape prisons of potential. But to imagine an entire singularity tunneling through its own horizon, pressing against reality like a fist against a thinning sheet, was a speculation that clawed at sanity. If this was true, what lay beyond that sheet? A new phase of spacetime, a bubble of false vacuum blooming inside the black hole, eager to inflate into its own cosmos. This was not idle fantasy. In the equations of inflationary cosmology lurks the possibility that universes can sprout like branches from deeper roots, each born in isolation, yet sharing a common stem. If the hum was the prelude to such a birth, then the void was no longer empty. It was a womb, but a womb is not benign to the world it abandons. If the singularity was destabilizing its own horizon, the local geometry could convulse, sending tremors of unimaginable violence outward. A runaway instability, a phase, transition in spacetime itself, could unmake the fabric that holds galaxies, stars, and atoms. In the quiet cadence of equations, some saw a whisper of apocalypse, a new vacuum expanding at light speed, rewriting the laws of physics as it goes, consuming everything in a tide no eye could see. Fear, unspoken but palpable, began to coalesce in the rooms where humanity keeps its knowledge. The hum was not just a puzzle. It was a question mark at the end of existence. And yet, amid this unease, wonder persisted. If the signal was real, if it was the sound of a singularity, evolving, crossing a threshold of being, then we were witnessing not destruction, but transformation. Perhaps black holes were never final acts, but passages. Perhaps the universe is not a static cathedral, but a living forest, its seeds slumbering in darkness until the hour of germination. Was this that hour? No answer came. Only the signal, rising with the indifference of tides. It spoke without voice, a note strung across the lattice of space-time, carrying with it the weight of a truth too vast for language. And in that hum, a choice lingered, not of action, for there was none to take, but of meaning. Was this an omen of unraveling, or an overture to a greater design? Was the singularity breaking its bonds, or opening a path beyond them? The universe, as always, gave no reply. Only the pulse continued, steady and inexorable, like the heartbeat of something vast awakening in the cold. In the silence of the cosmos, where observation meets uncertainty, the hum persisted. A single thread of resonance, pulling the intellect of an entire species toward the edge of comprehension. It was more than a signal now. It was a summons, and as the data spread through the corridors of academia and research stations orbiting Earth, the question deepened like a well without a bottom. What could awaken in the dark where even light cannot go? There were no easy answers, only the lattice work of theory, fragile against the weight of what the void might contain. Physicists, cosmologists, and philosophers stood shoulder to shoulder at the cliff of the unknown, each armed with equations, like torches, hoping to pierce the night. And what they proposed was as audacious as it was unsettling. The first came from the disciples of loop quantum gravity, a theory that seeks to weave the fabric of space-time into discrete threads, tiny loops that shimmer at the Planck scale. In this vision, a singularity is not an infinite collapse, but a bridge. Instead of plunging into a point of zero volume, matter reaches a threshold, then rebounds, a cosmic bounce. Could the hum be the echo of such a rebound, unfolding beyond the event horizon? If so, then inside the black hole something vast might be unfurling, not death but birth, another universe gestating in the dark, its first heartbeat carried to us as ripples in the sea of space-time. But others turned their gaze toward the holographic principle, the radical notion that reality itself might be projected from a distant boundary, as if the universe were the three-dimensional shadow of a two-dimensional code. In this framework, black holes are not devourers, but archivists, storing every particle, every vibration that falls within their grasp as holographic imprints on their surface. If the hum was real, could it be information bleeding back through the veil, a controlled release from the horizon? And if so, who or what controls it? Then came the darker proposition, false vacuum decay. In quantum field theory, the vacuum is not empty. It is an ocean of latent energy, a field humming with potential. Our universe rests, perhaps precariously, in a false minimum, a metastable state. A disturbance of sufficient violence could knock it free, triggering a phase transition that would rewrite the laws of physics in an expanding bubble of annihilation. Some wondered, whispered rather, whether the black hole's awakening might be such a spark, a tremor in the quantum sea that could unmake the cosmos. And beyond even that lay the architectures of brain cosmology, where our universe is imagined as a membrane floating in a higher dimensional expanse, like a sheet drifting on an unseen ocean. In these models, black holes might serve as pinholes, through which that deeper space presses against our own. If the hum is a stress signal, then something on the far side may be pushing, an unknown geometry, testing the tensile strength of the dimensions that cradle our existence. Yet as the speculations multiplied, so too did the audacity of imagination. For some, the data whispered of a possibility even bolder, a proto-universe, swelling like a seed within the event horizon, nourished by quantum fluctuations and space-time curvature. Perhaps every black hole is a chrysalis, and the hum is the vibration of emergence, the tremor of wings against a cosmic cocoon. Others dared to trespass beyond physics into the terrain of mind. Could the singularity be more than geometry? Could it be a quantum-conscious phenomenon, a feedback loop of information so dense that complexity ignites awareness? If thought can arise from neural webs of matter, why not from the webs of space-time itself, tangled in the infinite recursion of a singularity? If so, then the hum is not a random signal. It is a message, not crafted for us perhaps, but resonant with the pulse of something that knows it exists. And then came the final, most unsettling question, one that cast its shadow across every hypothesis like an eclipse. What if it's not alone? Cross-correlation studies began in earnest. Pulsar timing arrays, gravitational observatories, radio telescopes tuned their algorithms to hunt for siblings of the void-born signal. At first, the cosmos seemed silent, but then, faint, almost lost in the static, there were hints. Not one, but many, scattered across the scaffolding of the observable universe, like lanterns glowing at immeasurable distances, each flickering with its own cadence. Weak, ambiguous, but there. The possibility loomed like a second horizon. Multiple awakenings. If black holes were crossing thresholds, they were doing so together, as if bound by a deeper order, an orchestra tuning its strings in the dark. What could that mean? A synchronized process unfolding on scales beyond comprehension. A universal phase transition, where black holes cease to be endpoints and become architects of something greater. No answer came, only conjecture, branching like lightning across the minds of those who dared to trace its path. For some, it was terror, the prelude to cosmic erasure. For others, wonder, the dawn of an architecture so vast it could cradle infinity within infinity. And through it all, the hum endured, a single tone strung across the cosmos like a question mark, vibrating in the silence between stars. To listen was to feel the fragile weight of everything we know, and to sense, just beyond reach, the immensity of all we do not. Perhaps the hum is the universe asking itself what it means to exist, or perhaps it is not a question at all, but an answer, rising from the deep, carrying with it the promise, or the warning, that nothing, not even nothingness, is ever truly still. The hum did not fade. It lingered like a secret chord stretched across the fabric of space-time, daring the species that had just learned to walk among the stars to understand its rhythm. And so, humanity turned its instruments toward the void, straining to catch every vibration, every whisper carried on the gravitational tide. This was no longer the realm of curiosity. It had become an imperative, a call that reached beyond science into something deeper, almost primeval, the need to know. If the cosmos was speaking, then silence was no longer an option. The first sentinels stood already in orbit, their mirrors, cold and immaculate. Soon, they would be joined by others, machines more delicate than any bone, more patient than any mind. Foremost among them, LISA, the laser interferometer space antenna. Slated to unfurl its wings between 2025 and 2035, it would span millions of kilometers in a silent triangular formation, tracing its geometry against the black. LISA would not listen for the staccato bursts of cataclysmic collisions as its predecessors had. It would wait for the long, deep murmurs, the gravitational bass notes that ripple through spacetime like tides through a cosmic ocean. And if the hum belonged to that register, LISA would hear it. Back on Earth, another sentinel sharpened its gaze, the Event Horizon Telescope, a planet-wide eye built from radio dishes spread across continents. It had already painted the silhouette of the unseeable, a black hole's shadow cast against a halo of fire. But now, enhancements were underway. Finer resolution, faster data streams, adaptive algorithms that could map the shape of horizons themselves. For if something inside the darkness was stirring, the edge of the abyss might betray the first tremor. A distortion here, a ripple there, geometry shifting as though the void itself were breathing. Beyond these giants, a quieter army worked in concert, the pulsar timing arrays. They listened not to black holes directly, but to the cosmic metronomes, scattered across the galaxy, pulsars spinning with atomic precision, their radio pulses flashing like lighthouses in an infinite night. Any passing wave in spacetime, no matter how faint, would bend the rhythm of these pulses, leaving its fingerprint in time itself. Already, hints of a low-frequency background had emerged, a gravitational murmur spanning the Milky Way. Was the hum woven into that chorus, hiding among the signatures of ancient mergers? The search pressed on, yet instruments alone could not shoulder the weight of this mystery. To read the music of the universe demanded minds, augmented, accelerated, unrelenting, and so came the rise of AI-driven noise analysis, algorithms sculpted with the precision of mathematics, yet trained to dream like poets. They sifted through torrents of data, teasing out patterns too subtle for human perception, too fragile for linear logic. Were there harmonics in the hum, a structure in its cadence? Was this signal pure chance or a sequence, a code written in the language of gravity? But the thirst for resolution pressed even deeper, down toward the roots of physical law. If the hum was more than gravitational turbulence, if it hinted at dynamics beyond Einstein's great equations, then the next frontier lay beneath the Planck scale, where space-time itself quivers in quantum uncertainty. For that, new instruments were conceived, quantum sensors, exquisitely sensitive arrays that could register fluctuations so faint they seemed like whispers from another reality. They would not measure light, nor sound, nor even gravity in the classical sense. They would feel the trembling of the very lattice of existence, searching for an echo of the hum in the foam where space and time dissolve into probabilities. Each advancement carried with it a question, and each question widened. The abyss of wonder and dread. Was the pulse random, the artifact of turbulence in a black hole's turbulent heart? Or was it encoded, bearing the architecture of intent? If so, then every beat was a syllable, and the signal, a sentence waiting to be spoken. Others fixed, their eyes on the event horizon itself. Could its shape be changing? Could a black hole, once thought immutable, be flexing its boundaries like a living thing? If the horizon rippled, it would mark the death of a dogma, that black holes are eternal, prisons from which nothing escapes. Perhaps the hum was the first breach in that certainty, the sound of a door once sealed, beginning to unlock. And so humanity listens, harder than ever before. It listens across baselines that span planets, across frequencies older than galaxies. It listens in wavelengths of light and shadows of gravity, in the quantum jitter of the void. Each instrument is a question cast into darkness. Each answer, if it comes, will alter the architecture of everything we know. In the quiet rooms of observatories, in the silent orbits of satellites, in the sprawling supercomputers that hum with simulated universes, the search continues. 1 billion calculations trace the pulse. 1 billion hearts wait for its meaning. Perhaps it is nothing, a ghost in the static, a trick of the noise. Perhaps it is everything, a signal older than time, a message from the furnace of creation, or a warning whispered from the brink of annihilation. No one can yet say. All they can do is listen, harder, longer, deeper, until the hum reveals what stirs in the hollow of the abyss. In the aftermath of discovery, silence returns. Not the silence of ignorance, but the stillness of awe. The hum, the pulse, the tremor of meaning across space-time has left more questions than it answered. It has unsettled the certainties that once bound human thought, peeling away the illusion that the cosmos is a passive backdrop. For now, it seems alive, not with mind, not with malice, but with the cold inevitability of truths beyond comprehension. What does it mean if singularities can stir? If the dark hearts of galaxies, once thought immutable, possess states of awakening? Time, once imagined as a straight and slender arrow, begins to curl into shapes the human mind struggles to hold. For in the depths of a black hole, where gravity folds geometry into knots and causality fractures into ambiguity, the very notion of before and after collapses. Perhaps awakening is the wrong word. Perhaps it was never asleep. Perhaps in a realm where time has no dominion, awareness, whatever that means, simply is. And yet, the implications bleed outward. If such awakenings occur, if horizons ripple, with secret dynamics, could reality itself be recursive? Could the cosmos harbor seeds of other worlds, proto-universes gestating inside singularities, awaiting some threshold of tension to bloom? Brain cosmology whispers such possibilities, that our universe is but a membrane, its fabric pressing against others in a higher dimensional expanse. If so, then every black hole could be a womb, every collapse an opening, every hum a heartbeat of something waiting to be born. To contemplate this is to stand before infinity and feel the measure of fragility, for here is a species that emerged on a pale speck circling an ordinary star, fashioning tools of glass and metal to listen for whispers carried on waves of gravity, reaching across billions of light years. Against the darkness, they stretch, their senses and their minds tuning for harmonics in a silence so profound it feels eternal. And in that silence, they find something that seems to listen back, not with eyes or ears, not with thought or choice, but with inevitability. Perhaps this is the deepest revelation. That observation is never a one-way act. To measure the abyss is to be measured by it. To stare into the event horizon is to see, not reflection, but recursion, the truth that every question draws the questioner deeper into the weave of the answer. The hum is not simply data, it is dialogue. A dialogue without words, where the universe speaks in geometry, in frequency, in the curvature of its own being. But if the signal carries meaning, if it holds within its cadence the imprint of laws unknown, patterns undiscovered, what role does consciousness play? Not as the architect, but as the witness. The cosmos does not need permission to become. It does not wait for life to ask. Yet somehow, against the odds, a fragment of matter has awakened to awareness capable of wonder, capable of fear. And in that fragile state of knowing, it has heard something vast and intimate all at once. Could reality itself be conscious, not in the parochial sense of thought, but as an emergent symmetry, a self-sustaining feedback loop? Quantum mechanics hints at participation. That observation shapes outcome, that existence is not indifferent to awareness. If the universe is, in some sense, observing itself through us, then the hum becomes more than a ripple in spacetime. It becomes a mirror, a signal that says, you are part of the pattern you seek to understand. The philosophical weight bears heavily. If universes can birth universes, if singularities are thresholds to new realities, then mortality becomes not an ending, but a gesture. One breath in an endless tide of creation and collapse. Yet for all its grandeur, the thought does not diminish the urgency of the human condition, it sharpens it. For meaning does not reside in scale, but in connection, in the act of listening, in the courage to ask when answers may never come. And so the quest continues, though no longer with the illusion of mastery. Every instrument, every algorithm, every theory is a question flung into an ocean of uncertainty. Perhaps the signal will one day yield its secret. Perhaps it will remain forever beyond reach, a hymn sung in a language older than time. But either way, the search will go on. For what else is a species to do, standing in the shadow of eternity, if not listen harder? The night sky is not empty. It is dense with memory, with forces that predate the first atom and will outlast the last star. To live within such a cosmos is to dwell inside a cathedral whose walls are light years thick, whose pillars are galaxies, whose silence is louder than any sound. And in that cathedral, a whisper has been heard, a tremor that might be nothing or everything. Perhaps we did not awaken the singularity. Perhaps it has always been awake, waiting for us to learn the language of its silence.